Good morning, my dear students. Today we will discuss class 10 physics. That is, what is dispersion of light? What is the dispersion of light? Dear students, here, when white light is coming, that means this white light is a combination of 7 colors of light. 7 colors of light. That 7 colors are which one? Deep here. Deep here. Y means violet, indigo, this is blue, this is green, this is yellow, this is orange, and this is red. So you should remember by this word, that is vector. So dispersion of light means what is when white light passes through any transparent material. Suppose this is one prism. When white light passes through a prism, this is white light. When passes, that means in this case, this white light passes from rarer medium to denser medium. So in this case, the speed of this light, the refraction of this light, the 7 colors of light, that became difference. That means in this case, bending of light, it becomes different colors. Clear this one? So in this case, this white colors, it gets splitted. After splitted, it gives 7 different colors. So first one is which one? It is like this, deep here. That means the low bending, the lowest bending, the minimum bending of light is which one? Red color light is bends minimum, and violet color light it is bend maximum. So in this case, when white color splitted into different colors, that is known as what is dispersion of light, or it is also known as which one? Spectrum of light. Also known as which one? Spectrum of light. Clear? So this spectrum of light, or this dispersion of light, it is very important in our day-to-day, because the application of this dispersion of light is, we can take one example, that is what is rainbow. So how rainbow will form here? Because in this case, rainbow also acting, rainbow in this case, what is the water drops, that is like this type of water drops. These water drops working as a prism, like a prism. So in this case, suppose sun is here, and the light is white light. This is white light. White light is reflecting on the water droplet, and in this case, this water droplet will enter this light. That means in this case, this is rarer medium, and this is denser medium. So in this case, here the white light gets splitting into different colors, and it becomes what is? It gives the spectrum of light. When we are looking here, we are observing here, we can able to see the different colors of light which is emitted by this white light. So this is when we see, that means it is the different colors is coming. So in this case, what we can able to see the rainbow, and this rainbow is always opposite to the sun. Rainbow always form opposite to the sun. Here, why rainbow will form? Because the water working as a prism. So in this case, this white light gets splitting. After splitting, it gives the spectrum of light. Therefore, rainbow will be formed. Okay, next we will discuss which one. Next one is atmospheric refraction. Next we will continue what is atmospheric refraction. Dear students, you know that this is our earth. Suppose this is our earth. So in this case, on the earth there is a layer of air. That means this is the layer of air. Clear this one? So in this case, suppose this is the source of light is here, and you know that what is the ray of light which travel through a straight line. Suppose this ray of light which is travel a straight line. But here what will happen, because it is atmosphere. So in this case, this atmosphere, the temperature of atmosphere is not always constant, because temperature of atmosphere is, well, it is the upper layer of atmosphere, that is maximum, and the lower part of this atmosphere is minimum. That means this atmospheric diffraction, that means in this case the temperature of this atmosphere is different. And why? Because when sun is here, always after a few minutes, after a small difference of time, the atmosphere, the temperature of this atmosphere will be changes continuously. Therefore, what will happen? Therefore, refraction, the ray of refraction, the light which is travel through this atmosphere, that will be never travel through a straight line. It will be bends like this, curve, like a curve path. That means in this case, always, that means because temperature is, what is temperature is changes, therefore the bending of light, that means the refraction through light, that is also changes. Therefore, always it bends through this atmosphere. So in this case, what will happen? Suppose one object is here, and one person is, suppose, looking from here. Then the light which is coming from this source, when it entered this atmosphere, then it became curved. So when it became curved, the person he is able to see in a straight path. That means this object looks like a here. That means in this case, this is the apparent position. This is the apparent position of the object. And this is the actual position of the object. Actual position of the object. This is apparent position. Therefore, always this apparent position is above the actual position. So this is known as atmospheric refraction. And its application also very important. See here, in the night time, always we are observing what is stars and planets. Planets are here. See here. Suppose one star is here. One person is standing here, looking from here. Then atmosphere. This is the atmosphere on the earth. And when star is coming, due to what is scattering of light. So this due to atmospheric refraction, the ray of light from the star, it is coming just curved path. So in this case, due to the refraction of atmospheric refraction, the ray which is coming from the star, that is coming to this person with this curved path. But the person who is able to see this star in a straight path, that means at this position. That means this is become apparent position, this is become actual position. But see here, because the temperature of atmosphere is changing time to time. That means in a small difference of time, small duration of time, always the temperature will be different. When temperature will be different, after a few times, when another ray of light coming, it looks here. That means in this case, the apparent position becomes changes. Again, after some time, again when it looks, the apparent position becomes changes. That means in this case, the small difference of time, the apparent position of the star becomes changes. That means sometimes we are able to see at this place, sometimes we are able to see at this place, and sometimes we will see at this place. That means for a small duration of time, small interval of time, the apparent position of the star is changing. Therefore, we can observe sometime here, or sometime in this case. So, this is known as what is twinkle of star. This is known as which one? Twinkle of star. Clear this one? But see here, in case of planets are near from star, because star always away from us, but planets are near to the earth and size also bigger than stars. So in this case, these planets are not twinkle. Why? Because see here, this is also due to refraction. It is also a ray of light which it is also coming with a curved part. But see here, the apparent position, that is not much difference, very close to each other. That means it is not, we cannot notice this one, the apparent position. This is apparent position and this is actual position. So we cannot notice or we cannot able to notice the apparent position of the planet. Therefore, why? Because the difference is very small. Therefore, we cannot actually notice the different position of this planet. Therefore, in this case, these planets are not twinkle, but stars are twinkle. Okay.